Hi everybody, welcome to the first of the lab PowerPoints in which we're going to talk about some of the basics for your lab submissions, basic things that will cover all of your lab requirements for the next semester. So first of all, I'm Shannon Belmont. Nice to meet y'all. My office is in the BNR building if you happen to be on the Logan campus. I'm in 270H and please feel free to come by anytime. We are going to be establishing appropriate office hours, something that'll hopefully work for everybody by that doodle poll. So if you haven't filled that out yet, please do that. You should be able to find the link for that on the main Canvas page. My email addresses are listed there. I do respond quickest if you email me. If you want to message me via Canvas, go ahead and do so. I just don't respond to those as quickly. And about you, I do want to get to know you guys, and I want you to get to know each other as much as humanly possible in this kind of a setting. So if you haven't already set up your Google profile, follow the link on the main Canvas page to do that, and be as sharey and as specific as you like. This semester we have two goals. Number one is to get you comfortable using GIS. This means we're going to expose you to a broad suite of tools, all the basics and some advanced tools. You're going to learn how to not only use them, but how to evaluate how they work, and how to find resources to help you figure out how they work. We also want you to develop the habit of evaluating each step of the way. We want you to evaluate data that you're putting into GIS, how tools are running, how you approach spatial analysis, and what are the results coming out. You should have some sort of prediction of what you'd expect the results to be when you run some kind of tool in GIS. But we want you to get in the habit of checking out your results and making sure they make sense. The second major goal for the semester is to give you a fundamental understanding of spatial data. At its heart, it's an artificial way of representing the real world. So what does that mean, and how does that artificiality affect what we're doing and affect our ability to run analysis in GIS? How accurate and precise is the data? What's the quality? What's the resolution like? How does that impact what we're doing? And most importantly, the coordinate system. How do we describe where we are on the Earth? How do we take this spatial data and connect it to the Earth in an accurate way? And what are those coordinate systems? How do they impact the research that we're doing? Doing really intelligent GIS work is half the battle. If you can't convey the results of your analysis in a very convincing and trustworthy way, you really lose some street cred as a scientist and as a GISer. So we are definitely going to focus a lot of our attention this semester not only to doing really intelligent GIS work, but also creating very professional maps to make sure that you guys are putting your best foot forward when you present your data to the world. Labs are due Mondays before midnight. Some of the modules are 2 weeks long. There will be 2 labs in the 2-week modules. Late labs, they will be penalized 10%. This isn't your standard self-paced distance course. This course is really rigorous. It's aggressive. The schedule is unrelenting. And because the skills build on themselves and are cumulative, and because the schedule doesn't let up for the rest of the semester, this 10% penalty is sort of an inspiration to help you stay on track as best you can. Obviously, if you have some sort of unplanned, unforeseen issue, please contact me. Let me know if something's going on. I'm a flexible and very understanding person. But as a general rule, don't get behind. It's going to be hard to catch up. Okay, so for your lab submissions, you'll be submitting either a formal map, which is a map exported to PDF in ArcMap. A formal map is a term that I use loosely. It doesn't relate to the cartographic formal map. But I'm just talking about a map that has a title, it has a specific purpose and an audience, it has elements on it like a scale bar, legend, that support the map's purpose, and like I said, is exported to PDF. The alternative to that is a screenshot. This is basically just a snapshot of some step of your analysis. It's designed to save time, so you're not creating a formal map just to show us each step of the way. You'll be pasting a screenshot into a Word doc. It's always required to be cropped down to the extent of the meaningful data and then expanded to fill the page to kind of maximize the detail, and captioned. So a caption is going to work in lieu of a legend, scale bar, a north arrow, stuff like that. I want you to narratively state what's happening in your screenshot. Where is it located? What kind of analysis has been done? And then what does the symbology stand for? I'm going to show you an example of that. So to capture a screenshot, if you do a Control print screen on a PC keyboard, it'll capture your entire window. If you do a Control Alt print screen, and on a PC keyboard the print screen button is usually in the upper right hand corner. Mac users, you'll have to Google or do a grab or something like that. But anyway, Control Alt print screen will grab the active window. But again, what we want you to do is focus in on the extent of the meaningful data. So if you were doing some analysis in Logan, Utah, and I'll just say that this orange boundary right here is the municipal boundary for Logan, what we'd want you to do is crop in on that specific area. Once you grab this, you'll paste it into a Word doc, obviously, and then crop down to this extent. So this is what a cropped screenshot of that last image would look like, zooming in on the important details of the analysis. The caption should describe, like I said, what and where, the symbology, and offer credit to whoever your data source is. Data available at Utah HERC is an example of giving credit to the data source. So if you have questions, make sure you post things to the Google group, our discussion. If it's an emergency, post it there and then shoot me an email. So if I don't get the alert from Google groups right away, be aware that it's sitting there and I can get to it. Also use Google. YouTube is a fantastic resource. There's online dictionaries, your textbook. Esri has a whole suite of resources, and ArcMap itself has a help built into it. And definitely shout out to the course through our discussion board. This is going to be kind of a mantra slide that I slip in pretty much every week, just to remind you of these kind of basic goals. With GIS, you want to make sure you're analyzing and evaluating what you're doing. So what's going in, how does the tool work, what's coming out. Question what you're doing. And then manage your data wisely. This isn't going to matter as much this week, but as you start running some tools and doing some GIS analysis, you're going to find that the data gets out of hand really quickly. So set up your flash drive or set up a workspace on your computer and try and manage these projects week to week. Cartographically, remember you're trying to establish trust as a scientist and a GISer with your audience. So be deliberate. Don't add things to your map that don't need to be there, and be intuitive and engaging. Easier said than done. But that's it.